Okay, we're looking at the review for test number 9. This is quadratic equations number 1. First thing we're going to talk about is vocabulary. We have solution, 0, x-intercept, and root. Basically all the same thing. All these are where my graph intersects the x-axis. So it'd be point here and point here. Solution, 0, x-intercept, and root all basically are interchangeable. The only one that is a little bit different could be the solution. Sometimes whenever we say solution, instead of asking just for the x-intercept, we might look for something a little bit different. For example, we might use our ID and we might say, hey, where is it equal to 12? And we would graph that line at 12 and say, hey, where this is equal to 12 or y is equal to 12, my solutions, instead of being my x-intercepts right here and here, they'll be those points down here. So the solution could be other than 0. 0, of course, is going to be 0. X-intercept has to be 0. And the root is going to, right now, be 0 as well. There's a number of solutions you could have, or zeros, or x-intercepts, or roots. They could be 0. So if you have something like this, and I want to know how many zeros, it doesn't cross. So this would have 0. You could have one solution. So this would be like where it comes, touches, and turns around. Or it could have 2, like that, 1, 2. Next, we're going to look at solutions for graphs. First one we're going to deal with is going to have f of x equal to 5. For f of x equal to 5, we want to know x is my input. That's what I'm putting in. X is my input. I get out my y. So right here I know that my y is 5. So I'm going to take my ID, I'm going to slide it across where I is, and I'm going to draw a line. Doesn't have to be perfect, just close enough to see where the line is. This line is where y equals 5. This line where y equals 5 intersects this graph at 2 places. So I'm going to go all the way down and find the x value here. Go all the way down and find the x value there. So my solution here is where x is equal to -5 and -1. The second part of this problem, I'm given my x value, so I put -3 in here for x, and I'm looking for my y. So I'm looking for my y and I have my x. I'm going to go here to -3. Here's -3. This is what I'm given, and I just go up and find that point right there. To find my y, I have to stagger across over, move across over here, and that is 1. So my y here is 1. So instead of y, I would write f of -3 would be equal to, f of 3 would be equal to 1. Then we have a question here that says how many solutions would we have? Number of solutions, we have one here and one here. So we'd have 2 solutions. The last one, it says find where this equals 2. So where this one we had f of x, remember f of x is going to be like a whole equation like this, or whole expression, whole trinomial, quadratic trinomial. This is just equal to 2. So I want to know where all that's equal to 2. It's already graphed for us, so all we have to do, draw that line here. This is where y is equal to 2. Intersects right here and there. So we have this number and that number, which is that. So this would be equal to -4 and -1. After that, we have one that says I want to know where it's equal to -2. When it's equal to -2, it's anywhere on this line where y equals -2. and I don't see any intersections, so this would be no solutions. After that, we're going to look at tables. For the tables, we have two examples. The first table says it's finished. You're not going to be told on the test whether it's finished or not. You have to figure out if you have to extend the table or not. This one is finished. It says find f of x where f of x equals 2. Again, don't have my x, but I have my y. Here's my x, here's my y. I look down until I find 2. Hey, there's where y is equal to 2. When we're looking for roots and solutions and zeros and all that, always try to find 2. You may not have 2. Sometimes you'll have none, sometimes you'll have 1, but you can have up to 2. So try to find 2. I found 1. Oh, look, I found that 2 again. So it showed it twice. So x would be equal to 0 and 2. Just like we had 2 answers here and 2 answers here, we have 2 solutions. These are the same type of problem, except one you have the graph and one you have the table. Next, we're going to look at the one where the table needs to be finished. And the difference here is my table is not complete. It doesn't have all the possible values we could use. So what I'm going to do is I look here and I said it wants to know where f of x is equal to 20. I see 20. 20 is here. But like I said, try to find 2 because a lot of times they'll have 2. What we need to do is find the vertex first. This one right here is my vertex. If you look around it, all of the other points, they start repeating. So that means my next point over here will be a 12, and then my next point here will be a 20. I'll draw a little line. So this is how we fill this. We fill these in with this little rainbow thing. Then for this we follow the pattern: 3, 2, 1, 0, -1, -2, -3. My table is now complete, and you could extend this wherever. I just drew it in here to make it simpler for us to see on this paper. So where is it equal 20? Well, you have 20 here and 20 here. So that's -3 and 3. Then it asks how many roots. Oh, I didn't answer that for this one. How many roots does this one have? Roots are always 0. We have it once there, so you would have 1 root. On this one over here, roots would be my zeros, and I'm looking through this and I don't see 0 over here. Just to make sure we have none, let's look at an example. So my vertex would be 0, 4. That's about right there. And you see how all these values go up? So at 1 it'd be 8, which would be higher. At -1 it'd be 8, which would be higher. So my graph would look something like that. Is this ever going to cross the line? No. So this is going to look like this one and have 0 roots. So this is going to have no roots. It's going to have no roots, no solutions. Next page says roots given from equations, and I'm going to need a calculator, please. There we go. Easiest thing to do is do things in the calculator. So zeros. So I'm finding zeros. F of x equals, remember f of x is kind of like y. The whole thing's like y. So I can look in here and I can put x squared plus 12x plus 20, and look at the table. Before I look at the table real quick, I want to look at the graph to show us. If you look in the graph, you get an idea if there are going to be solutions. If you don't see it, sometimes you might have to zoom out using the zoom. This one I can see it. There's going to be a root here and root here. And we can tell just from the graph that's going to probably be -2 and maybe 9 or 10, whatever that is over here. So be sure I put the table and look and see where that's equal to 0. There is my -2. and negative 10. So x would equal negative 10 and negative 2. Next one. If you look at it closely, you'll see that this is the same. This part and this part are the same. So it's the same quadratic trinomial, except instead of finding where it equals 0, we want to find where it equals 48. So I'm going to continue going this way. There's 1, 48 there, so we have negative 14. And let's see if we can find the other one. We should have another one right here at 2. The third one in this group is a different one. It has a negative 48, but again, it is different. So I'm going to do y equals, this is going to be 2x and then negative 48. And we are going to look at the table. Now, it's not equal to 0, not equal to anything, but it's just f of x equals that, so we're automatically going to look at, well, it says x-intercepts here. So we want to know where it's equal to 0. Let's see, there's 1, negative 8, negative 8, and 6. So x equals negative 8 and 6 like that. These right here need to be factored. There will be some questions like this on a test. On the test, you will have to deal with the greatest common factor. This is 6 points of the test, so I'm going to do 1 or 2 of these. Probably going to do 2 of these, and you can do the third one. First one here, you always check for the greatest common factor. This one has a greatest common factor. All these numbers are divisible by 2. The easiest numbers to check for are 2, 3, or 5. So this one all have 2. So I'll do 2, and I'm going to divide all these numbers by 2. 4 divided by 2, 2x squared. 26 divided by 2, 13x. 30 divided by 2, 15. Now I can factor this. So in the box, I'm going to put 2x squared, 15 here. In the calculator, I'm going to set this up. So I will have 2 times 15 divided by x, and I will go ahead either retype it, or you can just put the y1 thing in and add x. I usually just, most of my kids just retype the parentheses of 15 divided by x, or you can do it that way here, depending on how your teacher taught you. And I'm just going to go to the table. And I am looking for 13. And do I see it here? There it is. 10 and 3. So I have 10x and 3x. Greatest common factor this way is 2x. Greatest common factor this way is x. Greatest common factor this way is 5. Greatest common factor here is 3. Make sure that works. Good. So my factors for this are 2x plus 3 and x plus 5 equal to 0. When we're solving by factoring, we have to set all these equal to 0. Set the equation and my factors equal, my quadratic and its factors equal to 0. And there's going to be this 2 in front of this. So those are my factors right here. These are my factors. To finish this off, I can ignore the 2 for now, and I need 2x plus 3 equal to 0, x plus 5 equal to 0. 2x plus 3, I got to subtract 3's from both sides. 2x, those cancel, equal to negative 3, divided by 2, x equals negative 3 over 2, and this one's going to be x equals negative 5. If there is no number in front of the x, you usually can just switch the sign on this number and get it. Now we'll come back to that later down here in the next section. This one over here, it has an equal sign that this one didn't have, but it's not set equal to 0. So I'm going to go ahead and just start this one for us. To get this set equal to 0, I have to add 5 to both sides. 6x squared minus 13x. Negative 10 plus 5 is negative 5. And that's now going to equal 0. From here, I can set the box up. 6x squared minus 5 will go in here. And again, I'll look for negative 13. I'm not going to finish that one for y'all. Y'all can finish that one. Then we'll look over here to the form factor from factor to 0. This is just what we did here when we want to find the zeros from my factors. Just like we did right here, set each one equal to 0. This one's really simple right here. There's nothing in front of the x, change the sign. X is equal to negative 7 here. The 2x plus 3 we have to set up. 2x plus 3 equal to 0. Minus 3, 2x equals negative 3, divided by 2, x equals negative 3 over 2. So those are the answers for number 1. For number 2, you work backwards. So we look at this, 4, so this is probably going to be x, change the sign, negative 4. The other one over here, x plus 6. 2 down here is done the same way. This one, you just set this equal to 0, then set this one equal to 0, just like we did here. These are probably going to be fractions. A number in front of the x, so we're probably going to have fractional answers. This one should be real simple. X plus 5, change the sign. This is a fraction. If we have a fraction, we're going to have a number in front of the x. For example, the number in front of the x here will probably be 3. So when we set this up, this will probably be 3x. There's your 1. Remember, you got to change the sign in there too. And this will be x plus 5. There's that one. You're going to finish number 3 on its own. Quadratic forms. Changing to standard form. All you have to do, go through the order of operations. I'm going to write the problem up here so we can do it. First thing you have to do is multiply this. You would multiply that with the box method. So set up the box, x plus 1, x squared, x, and 1. So we have x squared plus 2x plus 1. And we saw that plus 4 there. Switch it on over. Now we have to multiply 2x squared plus 4x plus 2. And we saw the plus 4. And the last thing we do, we're going to have 2x squared plus 4x, and then these are like terms, plus 6. Vertex on this one, vertex is always a point, has an x and a y value. X value comes from in the parentheses by the x. This is a negative 2 in the parentheses. Everything is opposite, so we need a 2. Out here is my y. Outside the parentheses, we keep the negative. Find the vertex and a point from this. One on the test shouldn't be as hard. This doesn't come out evenly in the calculator. What I'll tell you to do is x squared, plug it in, plus 7x plus 12. And then we are going to graph it. We're going to go to the table. And if you look for your vertex, where the one number that doesn't repeat, it's somewhere in the middle here. Now I know from doing this earlier that this is negative 3.5, negative 1/4. You're not going to have to do that, but if you want to do it on the calculator, if you go to the graph, you can do this and go to second calculate, and I want the minimum. If you look at the graph, there was a minimum. Move the little spider ball over here to the left of the vertex, and spider ball over to the right of the vertex, enter a couple of times, negative 3.5 and negative 1/4. Other point, now usually you'll be able to find it from the table, just the one lone number in the middle of repeating numbers. So I know it goes in here, just not showing up in the graph. I could change my table set. I can set up my table. blue window, and I can change this to 0.5, 1/2, and then look at the table. And I would see it here like that as well. See how the numbers on both sides are repeating? And there's my vertex. I could write that down. For this one, it is negative 3.5 and negative 0.25. And it asks for one other point, and I'm just going to use this negative 2, 2. Last part of this, and I'm done. We have find the value of y that gives you one solution, two solutions, no solutions for each graph. So we're just going to find out how many we give us and those points, or that point. The first one gives us one solution. The solution is at 2, 0. That is my x-intercept. That is my 0. That is my solution right here. That has one solution at 2, 0. If I was looking for solutions or zeros, roots, I could also have written that as x equals 2. This one has no solution. Does not cross here. This one, though, it could have a solution if I said it was equal to 7 or 8 or 5 or even 3. It'd have one solution here at 3. But at 0, there are no solutions. This one has 2, has a solution here and here. This point is negative 2, 0. This point is 2, 0. So my solutions could either be written, my x-intercepts for these, if I write the solution, if I just wanted the x value, I'd say negative 2 and 2. And we are done.